All right, what's up guys? In this video, we're gonna pick up some calculus here. We're gonna do another integration practice video. So I'm gonna evaluate the integral e raised to the x plus e to the x plus e raised to the x minus e to the x dx. Okay, so when you first look at this one looks a little challenging. I think the best thing to do here is to probably rewrite it a little bit. I would just rewrite this integral as the integral e raised to the x times e raised to the x plus e raised to the x times e raised to the negative e raised to the x, and then dx. So all I did was break it up a little bit. Now, why did I do that? Well, notice that when I actually rewrite this here I basically have a common factor of e to the x on both sides. So I can end up factoring one of those out, and that will make the integral vulnerable to a substitution. So here's what we got. We got e to the x because we have a common factor of that. And then on the inside, we just have e raised to the e to the x plus e raised to the negative e to the x, and then dx. So it set this up perfectly for a substitution. All right, so the substitution for this is pretty obvious. We want to let u equal e to the x. We can then take the derivative, which gives us e to the x dx. Then we get 1 over e to the x du is equal to dx when we actually solve for dx. And so what happens is the integral then becomes e raised to the u plus e raised to the negative u, and then du. So remember that when you solve for dx, what's going to happen is the e to the x that was on the outside that we factored out at the beginning would actually cancel out. So that's what happened to that. Then this is just a simple integral now. And sorry, I've not been utilizing the equal signs. Apologize. So we can break this up using properties of integrals as the integral e raised to the u du plus the integral e raised to the negative u du. And we can deal with the integrals separately using those properties. Okay, so it's pretty easy to see what we're going to get here. Antiderivative of e to the u is just e to the u. Antiderivative of e to the negative u, that's going to be minus e to the negative u. And then you'll need to tackle on a plus c. And then to finish the integral off, all you have to do is put the u back in. So remember that u was e to the x. So all you got to do is put that back in for the final answer. So your final answer for this this integral here, so we needed to integrate e raised to the x plus e raised to the x plus e raised to the x minus e raised to the x, and then dx. So you can write your answer as e raised to the e raised to the x, or e raised to the e raised to the x, minus e raised to the negative e raised to the x, and then put a plus c on the end. And that would be the solution. All right, so let me circle that for you. And that's how you solve it, or how you evaluate it. So if you have any questions about how I obtain my answer for this, just let me know. I'll be more than happy to talk about it with you further. All right, I'll see you guys next time. Y'all take care.